Hi and welcome to BioTalk by IB Girls, and this time we are going to talk about surface area to volume ratio, whereas my friend Melissa talked about cell theory and exceptions to the cell theory in the previous video. The rate of material exchange in and out of a cell is a function of its surface area. As the cell grows, volume increases faster than surface area, leading to a decreased surface area to volume ratio. And if the metabolic rate is greater than the rate of exchange of vital materials and wastes, the cell will eventually die. So we all know that surface area to volume ratio is important in the limitation of cell size, and I'm going to show an example of why and how it can be calculated. We know that in the cytoplasm of cells, the large numbers of chemical reactions, they take place there. These reactions are known collectively as the metabolism of the cell. The rate of these reactions, which is the metabolic rate of the cell, is proportional to the volume of the cell. And for the metabolism to continue, substances used in reactions must be absorbed by the cell and waste products must be removed. And this is why surface area volume ratio is very dependent, or this movement with the products going in and the waste going out is dependent on the surface area to volume ratio, and we are going to talk about that much more in depth. So yeah, basically the substances move into and out of the cells through the plasma membrane at the surface of the cell. The rate at which substances cross the membrane depends on the surface area. And here we refer back to that surface area is actually important in terms of substances moving in and out. Yeah, if the ratio is too small, then the substances will not enter the cell as quickly as they're required. And waste products will accumulate because they're produced more rapidly than they can be excreted. And if we go to this slide, this slide, which is the calculations, we can calculate and see the cohesion between the total surface area and the total volume. So we start by this example. Sorry, it should have said cell size in centimeters. And these are, we're going to assume that they're cubes, so it's going to be 1 by 1 centimeter cube. And how we got here to this total surface area is simply by saying 1 multiplied by 1 multiplied by 6, because we do have 6 sides on a cube, which is equal to 6. When we go to a cube of 2 centimeters by 2 centimeters, it's going to be 2 multiplied by 2 multiplied by 6, which is 24, and so on with the 3 as well. 3 times 3 multiplied by 6 is going to be 54, and so on and so on. And the total volume, you guys should know this as well. That is 1 multiplied by 1 multiplied by 1, 2 multiplied by 2 multiplied by 2 is equal to 8, and 3 times 3 times 3 is equal to 27, and so on. The thing that we are most interested in is the surface area volume, which actually is very easily calculated. It's saying the total surface area divided by the total volume of the cell. So it's 6 divided by 1 equals 6, 24 divided by 8 equals 3, 54 divided by 27 equals 2, and 96 divided by 64 equals 1.5. So this tells us that the small cells have a much bigger ratio than the bigger cells. So the cell of 1 centimeter by 1 centimeter has a bigger ratio than the cell with 4 centimeter by 4 centimeter has, which is only 1.5. That tells us that a cell with a big surface area volume equals a small cell, which equals a very good thing, because we know as the cell gets larger and larger, the surface area is increasing, so is the volume, but they are growing at a different rate. And this is why surface area to volume ratio is very important, because we get a smaller surface area volume ratio when the cells get bigger. And if we go back here to the first slide, if the metabolic rate is greater than the rate of exchange of vital materials and wastes, the cell will eventually die. This is a cause that, as we stated before, if the ratio is too small, the cells may overheat because of the metabolism producing heat faster than it is lost over the cell's surface. So this is why we've covered basically everything in the limitations on cell size that is explaining the surface area to volume ratio. Basically covering it all. I'm just going to use the word basically again. But we have, through this presentation, explained why cells are small and how they work best when they have a big surface area to volume ratio. Yep. Thank you guys, and see you next time.